Are you ready to embark on a transformative journey? Let the sunshine of the college ambience illuminate your journey and awaken your spirit in the refreshing green surroundings of the campus. Success starts with you. Chase your dreams relentlessly and strive for greatness. Live your life the way you imagined. Dream big. Ignite your passion and achieve more. Unlock your potential and discover your brilliance. Welcome to Aditya University, the world of opportunities and the place where dreams become reality. A 180-acre sprawling campus nestled in a picturesque location, Aditya is a landmark on a map of the nation for quality education, elevating the education standards with NAC A++ grade, project-based learning. Diverse students from across the globe converge here in search of knowledge. At Aditya, we foster a dynamic learning environment that nurtures curiosity and encourages critical thinking. Our cutting-edge facilities and research opportunities provide you with hands-on experiences, preparing you for the challenges of the real world. At Aditya, we empower you with the tools and connections to succeed in your chosen field. Our dedicated career services team is there to support you at every step of the way. The canvas of the future is yours to paint.
A place where minds think beyond the horizon.
Aditya is a premier university providing advanced professional and technical education to future industry technophiles with recognition of NAC A++ and NBA for its quality education. Aditya University adapts a multidisciplinary technological approach integrating research, community engagement and sustainable practices.
I'm so fortunate to be guided by Aditya because they help me understand the complete treasure of the placements since the very beginning of my graduation life. By providing the necessary training on aptitude, reasoning and soft skills and also groom me to work on the requirements of the companies. The right place to get placed is always Aditya.
As a placement flagship, Aditya creates numerous opportunities for budding technocrats. Aditya University offers an unparalleled learning environment. Our well-designed classrooms, fully equipped laboratories, advanced research facilities, and cutting-edge technology ensures that students have access to the resources they need to excel in their fields. We take immense pride in our distinguished faculty, comprising highly accomplished professors, industry experts and researchers for inspiring students to push boundaries and explore new horizons. At Aditya, we understand the importance of bridging the gap between academia and industry and establishing strategic partnerships with leading corporations.
Center of Excellence is a facility with necessary infrastructure to enhance the skills of students. These centers provide ample opportunity for the students and staff to comprehend with the latest industry practices and to upgrade their knowledge through industry-relevant projects.
These collaborations ensure that our graduates are industry-ready and well-prepared to tackle real-world challenges. Aditya's Technical Hub is an in-house corporate training unit that enhances practical skills and fosters creative thinking by conducting regular competitive events in association with our industry-recognized certification partners.
Aditya is one among the top universities in India. It gives path for the global interface between students and officials. More pedagogy for high standards are set in place for the betterment of the students.
Aditya offers engineering, pharmacy degree and management studies. We believe in holistic development and offer a vibrant campus for our students. Life at Aditya goes beyond academics.
It is a great platform to explore our inner interest in both curricular and co-curricular activities. I am grateful for the exposure it has given besides my core subjects.
I'm so glad to be at Aditya. The strength of Aditya lies on its diversity. Students from all over the world, they come here in search of knowledge.
From technical clubs, cultural societies, and sports team to student-run organizations, there are ample opportunities to pursue passions. International exchange programs and collaborations with renowned universities abroad.
Being a student of Aditya, it's such an enriching and a fabulous experience. The creativity and the development which I have evoked got a lot of confidence through the various platforms, as I'm a member of UIF, which means the University Innovation Fellowship, which empowers the students and the teachers to lead a change in the world.
Aditya is a place where cultures intertwine and spirituality finds its home. As a part of our vibrant hostel community, you will have the chance to meet people from diverse backgrounds, fostering lifelong friendships.
Hostel life at Aditya is an unparalleled experience. The facilities which are provided to the students, keeping in mind their comfort and convenience, is unmatched. The hostels are spacious and have an amazing aura and greenery all around.
Modern spacious rooms, high-speed Wi-Fi, 24/7 security surveillance and access-controlled entry points, diverse cafeteria cuisines, state-of-the-art gym, celebrating the spirit of youth, creativity with a lineup of electrifying events. Aditya University, Surampalam, Andhra Pradesh.
Once again, good evening all. A warm good evening and a warm welcome to all distinguished guests, respected faculty members, and enthusiastic participants to 1 week online ATAL FDP on AI and simulation in additive manufacturing, starting from 3rd February to 8th February 2025, organized by Department of Mechanical Engineering, Aditya University. Today marks the beginning of a significant journey of learning, collaboration, and professional growth. I would like to give a brief introduction to our university, which is providing a dynamic learning platform for enthusiastic learners, offering various programs that foster academic excellence, innovation, and success. Aditya University. Aditya University is a premium institution of higher learning located in the heart of East Godavari district, Andhra Pradesh, India. Established in 2001, Aditya University is a private university dedicated to providing quality education, research, and innovation. With a sprawling 180-acre campus, Aditya University offers a diverse range of undergraduate, postgraduate, and doctoral programs across various disciplines, including engineering, pharmacy, business management, arts, science, and humanities. Our university is committed to fostering academic excellence, entrepreneurial spirit, and social responsibility among students. Over the course of next few days, we will dwell into cutting-edge research and practices in the fields of artificial intelligence, machine learning in additive manufacturing, and Industry 4 and advanced manufacturing techniques. Over the next 5 days, you will be engaged and renewed resource persons to gain insights into the field of artificial intelligence, machine learning, and their applications in additive manufacturing, Industry 4, and challenges faced by the various advanced manufacturing processes. Now, without any delay, I would start today's session by inviting our distinguished guests to online session. It is my distinct honor to invite Dr. M. Srinivas Reddy sir, Deputy Pro Chancellor, Aditya University, to join this session. Meanwhile, I will share my screen. Okay, sir. Okay. And it is my distinct honor to invite Dr. M.B. Srinivas sir, Vice Chancellor, Aditya University, to join us in this section. And it is my honor to invite Dr. S. Ramasri Madam, Pro Vice Chancellor, Aditya University, to join this session. And as well as I extend my warmest welcome to invite Dr. G. Suresh sir, Registrar, Aditya University, to join this online session. And it is my honor to invite the Dr. Sanjay Dola sir, Dean, School of Engineering, to join this session. And finally, I would like to invite Dr. S. DDV Dimesh Reddy sir, Head of the Department, Mechanical Engineering, Aditya University, to join the online section. And it's my pleasure to invite the co-coordinator of this event, Dr. Mohammad Jubairuddin, Assistant Professor, Aditya University, to join the session. And now let us start the session with the national song. As we begin prestigious faculty development program, let us pay our tribute to our nation by singing the national song Vande Mataram. Not audible, sir. Thank you everyone for your participation. With the spirit of unity, let us now move forward. As we begin with this esteemed one-week online ATAL faculty development program, let us invoke the spirit of knowledge and enlightenment through the ritual lighting of the lamp. Lighting the lamp symbolizes the dispelling of darkness and ushering in of wisdom and prosperity. Thank you. Now, I would like to invite the coordinator of the ATAL FDP, Dr. Mohammed Jibairuddin, to share the report of ATAL FDP for all these 5 days.
Good evening to all of you. Good evening to all esteemed speakers, participants, and guests. It is a privilege and honor to welcome all of this 6 days AICT ATAL online faculty development program on AI and simulation in additive manufacturing, organized by the Department of Mechanical Engineering, Aditya University, Surampanagar. We are delighted to have more than 150 plus participants joining from the IIT, NITs, government colleges, universities, and private institutions across India. This diverse participation reflects the growing interest and the importance of AI-driven advancement in additive manufacturing. We are also proud to host 13 distinguished speakers from the premium institutions and industries, including IIT BHU, IIT Bombay, NIT Allahabad, National Institute of Advanced Manufacturing, Ranchi, BITS Plani, Bhabha Atomic Research Center, Mumbai, Indira Gandhi Center for Atomic Research, Kalpakam, RTH Asian University, Germany, Dongkyu University, South Korea, and experts from the industry like TCS Bangalore, Deloitte Consultants India, Hyderabad, Hexagon Bangalore, and M2 Next Solution Private Limited, Bangalore. This FDP aims to provide deep insights into AI application in additive manufacturing, covering the topics such as simulation techniques, process optimization, material modeling, and advanced manufacturing technologies. I extend my sincere gratitude to AICT ATAL Academy for approving online ATAL FDP. Also thanks to Dr. Seshya Reddy sir, Chancellor Aditya University, Dr. N. Satish Reddy sir, Pro Chancellor Aditya University, Dr. M. Srinivas Reddy sir, Deputy Pro Chancellor, Dr. M. B. Srinivas sir, Vice Chancellor, Dr. S. Ramashri ma'am, Pro Vice Chancellor, Dr. G. Suresh sir, Registrar Aditya University, and Dr. Dawla Sanjay sir, School of Engineering, Dean School of Engineering, for their continuous support and fostering innovation and skill development among the faculty members. And finally, our beloved HOD, Dr. Vimesh Reddy sir. A heartfelt thanks to all distinction speakers and because whose expertise and knowledge will guide us in this learning journey. I encourage all participants to actually engage in the discussion, ask questions, and make the most of this opportunity to enhance their understanding for this transformative field. With this, I declare AICT booked, and thank you. Thank you so much.
Thank you, sir. Thank you for a brief report on this all 6 days online ATAL FDP program on AI and simulations in additive manufacturing. Now, let us hear from our esteemed dignitaries to share their thoughts and vision for this FDP. Now, I would like to invite Dr. Dola Sanjay S., Dean, School of Engineering, to address the online participants gathering regarding this FDP. Sir, please, sir.
Good evening, everybody. I wholeheartedly welcome all the participants to this online FDP, ATAL FDP. I wholeheartedly wish and congratulate the Department of Mechanical for taking this initiative. And I thank AICT for sponsoring ATAL FDP, and make sure that these are the platforms where we can try to exchange and impart knowledge. And I wish all the online participants see that you gain the knowledge, share the knowledge, and make sure that this if FDP is interactive, and make sure that you learn a lot of things and implement for the society and environment. I wholeheartedly wish every individual all the best. Thank you, one and all.
Thank you, sir. Thank you for your valuable words. And now I would like to invite Dr. SDDV Bhimesh Reddy, sir, head of the department, to address the gathering.
Thank you very much, sir. Good evening, dignitaries. It gives me immense pleasure to welcome you all to this faculty development program under the ATAL initiative. This program is designed to provide a platform for knowledge sharing, skill enhancement, and professional development in AI and simulation in additive manufacturing. AI and simulation technologies are transforming the field of additive manufacturing by enhancing the design process, improving material efficiency, and optimization production workflows. There are some benefits like cost reduction, improved speed, and also enhanced customization. And I extend a warm welcome to our today resource persons, Dr. Ashutosh Mishra and Mr. Syed Abri Husni, who have graciously joined us to share their expertise. Your presence will inspire and guide us throughout the session. To my fellow participants, I appreciate your enthusiasm and commitment to learning. Let's make this program interactive, engaging, and also impactful. Once again, welcome to all, and I wish you a fruitful and enriching experience ahead. Thank you. Thank you, one and all.
Thank you, sir. So to all the participants, these are our pillars of our Aditya University. Dr. N. Sheshare, Chancellor for Aditya University, and Dr. N. Satish Reddy, sir, Pro-Chancellor, and Mr. N. Deepak Reddy, sir, Pro-Chancellor for Aditya University. These are the pillars for our Aditya University. Now, without further delay, we are going to start the session. I will introduce today's first session speaker. Dr. Ashutosh Mishra, Assistant Professor, NIT Allahabad. We are honored to welcome Dr. Ashutosh Mishra as a distinguished speaker for the AICT ATAL online FDP on AI and simulation in additive manufacturing. Dr. Ashutosh Mishra. Sorry to interrupt, sir. 1 minute. We are honored to welcome Dr. Ashutosh Mishra as a distinguished speaker for the AICT ATAL online FDP on AI and simulation and additive manufacturing. Dr. Mishra is an assistant professor at Motilal Nehru National Institute of Technology, Allahabad, India. He was awarded the prestigious DGFS fellowship to pursue his PhD in mechanical engineering from Homi Bhabha National Institute, India, which he completed in 2016. He also holds an MTech in mechanical engineering from IIT Varanasi, completed in 2009. His research expertise spans thermomechanical studies, structural mechanics of composites and 3D printed materials, mechanics of energy storage materials, and thermal and mechanical abuse testing of batteries. His work focuses on the multi-domain applications of mechanics, contributing to advancements in materials science and engineering. Dr. Mishra has industry experience as an application engineer at Clyde Pumps India Private Limited, where he managed several government turnkey power projects. His academic contributions include 2 book chapters, 21 journal papers, 3 patents, including 1 granted, supervision of 15 plus MTech and 4 PhD scholars. Currently, he serves as the principal investigator for multiple funded research projects from ISRO, DRDO, and Indian Railways, demonstrating his strong involvement in cutting-edge research. With over 8 years of teaching and research experience, Dr. Mishra continues to make a significant impact in this field. We look forward to an enlightening section with him. Welcome, sir. We welcome you to today's section. Now I am handing over to the section to Dr. Mishra, sir.
Thank you, sir. Am I audible, sir?
Yes, sir. Yes, sir.
Okay, okay. So let me share the screen. Okay, is it visible to you, sir? The screen is visible?
Yeah,
Yes,
visible.
sir. Yes, sir.
Okay. Yeah, thank you, sir. And I want to express my sincere thanks to Vice Chancellor, sir, Pro Vice Chancellor, ma'am, and deans, registrar, heads, participants, and other faculty members, and upcoming faculty members also. Now, I have been given this opportunity to present my expertise to you and to make you benefit or to open an arena of new direction of application of mechanics in the field of 3D printed steels. So, considering the theme of the FDP, I have included the results which relate to additive manufacturing. However, there are several other results and several other uh, studies are there in the field of additive manufacturing, which I have, I've conducted. But a very short presentation I have included here in this FDP. Now, before I proceed, I would like to thank you for your detailed brief introduction. It is a detailed brief introduction, and since I belong to NIT Allahabad, which is popularly known as MNNIT or Motilal Nehru National Institute of Technology, Allahabad, in Department of Mechanical Engineering and there are 2 departments, Department of Mechanical Engineering and Department of Applied Mechanics. So I belong to a Department of Applied Mechanics, and actually the mandate of Applied Mechanics is to apply the knowledge of mechanics in several diverse fields. So considering the aim and mandate of Department of Applied Mechanics, I have extended my research study in different arena of mechanics, such as additive manufacturing and battery mechanics, biomechanics, mechanics of composite materials, and metal mechanics. Now, my basic expertise or my PhD research work was done in the field of mechanics of metals. So I have extended this metals, the expertise of metals in the field of extending it to additive manufacturing of metals. So mechanics of metals printed through FDM, mechanics of metals printed through, there are new techniques also. So there are involvement of mechanics in all these fields. So one of the field I have covered in my presentation, that is mechanics of additive manufacturing for metals. So I'll briefly introduce the concept of, or the something related to mechanics. My presentation covers two different aspects. One is additive manufacturing, then the second aspect is experimental and numerical modeling. Now, if you before I go further, I would again request all the participants to raise your hand, or you can speak in between, you can interrupt in between in if there is any disengagement between the during the session because of internet issue or anything. So you can raise a voice and I'll stop, because as a teacher we keep on teaching, and we keep looking at the students, but there are no students, all are upcoming faculties, and I cannot see you all. So the thing is, I'll have to rely on the internet connectivity, and if at all there is any disconnection, please let me know. Now, the part one of my presentation covers additive manufacturing, which actually introduced the something about additive manufacturing, then key research areas of our group at NIT Allahabad. I'll briefly cover what we are doing at NIT Allahabad. Then introduction related to additive manufacturing, how it works, then products, the diversified aspects of additive manufacturing, how diversified additive manufacturing can be, that is represented in terms of the types of products which can be produced by additive manufacturing. And now we are very well aware of its capabilities. When I started exploring the field of additive manufacturing long back, around 7 to 8 years back, when I was doing PhD work, and that time also I was exploring the application of this particular new technique. And then I'll cover the broad classification, research scope, and motivation. Then afterward, once the part one is covered, then I'll introduce my work, which was experimental and numerical modeling. And it will cover the design of SLM printed part, experimental methodology, numerical modeling, results, and discussion. Now, considering the theme of your FDP, with what we have, what I have seen, that there is a numerical part which needs to be discussed. So I've included slides of numerical modeling, and I'll be covering the numerical aspects of how additively manufactured parts can be modeled through several FEM softwares. So modeling of such part is still very less explored by researchers across the globe. So I've covered such aspects in my presentation, and then conclusion and references. So part one starts with this additive manufacturing. Now, if we see what is additive manufacturing, for those who are new to this field, I'd just like to elaborate here that I've included this this printer. If you see this printer, this is a 2D printing. Now the printer is saying please add one more dimension, means if the real object is to be printed, then how it can be done. It means there is a third dimension, addition of the third dimension. If we can do, then that is called as 3D printing. So any product, if it can be extended in the third dimension, that can be a additively manufactured product. Now the term additive manufacture and 3D printing is slightly different, but that is a different aspect which I'll cover maybe later. But additive manufacturing includes layer by layer addition, as we all know, that we add, once a layer is deposited, another layer is put over it, and a cube can be formed by depositing layer over another. So a cube can be formed. So similarly, consider it as a two-dimensional object. Now if it is a three-dimensional object, it is a cube. So this layer by layer addition, it's called additive manufacturing. It's now unlike subtractive manufacturing, where we use machining, milling, and there are several other operations. Now I have tried to show this schematic or schematic 3D printer which has X, Y, and Z axis. So if XY layer is formed, then we can add Z axis, and finally we can get a final manufactured product or a prototype of a product or a model. So we have layer of application of additive manufacturing. Layer of application means we can manufacture a final product, although we require some certain finishing operations also. Yes. Now, coming to the application, I've included this particular this slide, which actually covers the two aspects, that is rapid prototyping and rapid manufacturing. All this falls under additive manufacturing, as we know that we may require development of prototyping before actual production of a product. So rapid prototyping, its application of additive manufacturing is rapid prototyping and as well as rapid manufacturing. It means the final product can also be manufactured by this application, by this additive manufacturing. And there are several precise, improved, advanced additive manufacturing process nowadays, which are actually being used for manufacturing of the final finished product. Of course, certain finishing operation post and some treatments are required, but the shape and geometry at this point is the desired one, which we require for the supply of the product or the final product. Prototype can be a model prototype, or it can be a scaled down model, or anything for proof of concept, something like that. So the application of additive manufacturing includes prototyping and manufacturing both. The part is manufactured as, if we can see, the part is manufactured by the deposition of material, and it is used in a wide variety of industries, from shoe to car manufacturing. As we have seen long back, a car is made up of carbon fiber. A single as a car was made by additively manufactured parts, and then it was assembled. So at this point of time, I cannot say the whole car was made additively manufactured through additive manufacturing route. But what I can say that there are certain aspects, like there are 100 components, 1,000 components. Then out of those 1,000 components, there are around 100 components which can be made by additive manufacturing route. The application of additive manufacturing ranges from it has a wide range of application, what I can say. Nowadays it is being used in several space applications also, like nozzles of space rockets are also being manufactured by additive manufacturing routes. And I've seen that also, because I'm currently handling ISRO project. I've seen that part also. Now, other names of rapid prototyping are rapid prototyping, layered manufacturing, or generative manufacturing, because we generate the final product layer by layer. So it is called as generative manufacturing also. Now, as we see, rapid prototyping, it has a solid image modeling. Functional prototyping means it can be a solid image modeling, functional prototyping. These are all the different names of rapid prototyping, which is actually used for generating the prototypes of a product as a model, or as a scaled down model, or a full scale model. Then rapid manufacturing, as the name suggests, it is again direct tooling or direct manufacturing, means we get a final product. So this is a brief introduction of additive manufacturing. This GIF shows how addition of the layer is taking place. Deposition of material is being done layer by layer. This GIF image shows the addition of these layers. finally a product will be formed. Now, if we see direct manufacturing, we have an example of 3-unit dental bridge. So nowadays, dental bridge are, it means dental problems are common nowadays, and if ceramics, if we take such problems, we try to resolve such problems. If we have some techniques so that we can get the image of the gap between two teeth. So in those sections we require some, that is actually the lengthy process, and if we have certain techniques so that we can get the image of the three-dimensional image of the gap between two teeth, then we can we can use it for generation of SLS files, and then we can directly make a dental bridge by using direct manufacturing with the full scale model. Considering the full scale model, if we see for metallic or metal based 3D printed products, there are certain literature which reports that their strength is better than the conventionally made parts. So I'll discuss later in the second part how the strength of these metal products can be changed. Now this is another example which is actually used to make a steel mold for blow molding. Then it is a common now it's a very common news. Every now and then we see that the house made up of additive manufacturing as being means manufactured by additive manufacturing in India and abroad also. In India, IIT Chennai or somewhere it has been already tested, it has been made. So it's a common product which is in news nowadays. So the house was built, this I have included, that the house was built in 24 hours by using 3D printing technology. This is just to give you a glimpse of application of additive manufacturing. It ranges from several, from consumer goods to research products. And even houses at such a large scale also it can be used. Now, broadly, if we classify additive manufacturing, we see that it can be classified. It's a very broad category. However, there are several other classifications, but this is a broad classification, such as this is liquid-based printing, solid-based printing, and powder-based printing. Now, if we see the liquid-based printing, we have raw material is liquid. The common liquid-based printing methodology is SLA, stereolithography apparatus. Then we have a solid-based additive manufacturing or 3D printing method, that is raw material is solid. Commonly used process is FDM, that is fused deposition modeling, which is widely used for polymeric material or thermoplastics. So it's widely used technique, and one of or few of the results I've included from FDM. Means FDM was conducted, and FDM was used for one of the research work which I had done earlier. So I've included few results of that work. Now the third is powder-based printing. One of the common powder-based printing is powder bed fusion technique. That is means actually the SLM falls in this category. So powder-based printing, if we see the material is powder, and the selective laser sintering or SLM, if we see SLM, that is selective laser melting. So SLS and SLM both are actually the type of powder based printing, and mostly they are used for metal parts, for fabrication of metal parts. So I'll be covering, my study will cover this particular type of printing, wherein I have used SLM particularly for making the part. Now if we see the research scope and motivation of additive manufacturing. I've tried to include the introduction, when rapid prototyping was introduced, because long back when I was pursuing my BTech, I did my BTech in production engineering, and at that time also I used to study rapid prototyping, but its realization actually I've seen somewhere here. So at this I've seen its parts also. So we can see it's not a very new term. It has been introduced in 1988, but later on, if we see, the progress is very high, and the time duration, if you see, we can see the products, different kind of product, different class of products are being manufactured by this particular method. So evolution of 3D printing, if we see, the scope of its application are increasing year by year. The potential industries includes furniture making, housings, aerospace, jewelry, defense, and etc. There are several applications of it. Now, if we see the research gap areas, actually, in particular, if we focus here, liquid-based printing and solid-based printing, these are actually being done in India also. It is very common practice nowadays. So if we focus these two type of techniques, I hope I'm audible to all.
Yes, sir.
Okay. So if we focus these two type of techniques, we have enough scope of developing relevant materials, developing a suitable design. Then we have process innovation, part characterization, and failure modeling. Now, these two still need some research, and there is a tremendous scope of carrying out research in these two fields. I am not saying that this particular, the third type, that is powder based printing techniques, does not require research insights, further research insights. But why I am saying these two require further research or more research, because the strength of the part which are manufactured by using these two techniques are still very compromised compared to conventionally manufactured material or conventionally manufactured product. However, in this case, the third type of printing, either means, if we actually, I have also noticed, and the literature also reports, that the products which are manufactured by this material, there are cases where it has been seen that they have superior quality. It means they are exhibiting superior mechanical properties. So superior mechanical properties are being exhibited by powder based printing. It's a very advanced technique, and the machine is very costly. Moreover, if we see the cost, precision, and several other aspects like mechanical properties, finish, and all, it is very high. It is very high, very good. And certain post processing is required to get a final product with equivalent strength and mechanical properties. And of course, the time requirement, or it requires a specific product. For large scale production, this particular product, this particular technique is not suitable, of course. And now, for specialized products, for a special purpose manufacturing, we can use this particular technique. So however, there is still a scope of improving several properties, like most of the mechanical components undergo fatigue loading. Now fatigue, again, since the components undergo fatigue loading and its failure, means the failure studies under fatigue loading is again an underexplored area of research for this particular type of, technique of additive manufacturing. So considering the significance of this particular type of additive manufacturing, that is powder based printing, I have particularly chosen SLM based technique to manufacture a part or a component at a specimen level to study the fatigue load. So the part 2 actually covers the aspect of SLM based printed specimen and under the fatigue load. Now, again, if we see the research gap for third type of, that is for powder based printing, if we see, there are plenty of materials which can be used for making additively manufactured product. But for each material, the process, the laser parameter and the parameter, means printing parameters, will differ. So there are scope of material changes, there are a scope of design changes, there are scope of process innovation, part characterization, failure modeling. Now the thing is, the difference between research in this area and this area is the mechanical behavior of parts manufactured using these two techniques have very inferior quality. It means very inferior. They do not exhibit, or they are very less, means they have inferior mechanical properties, and there are significant scope of improving the process such that we can have a better part compared to conventional, of course. The only thing is, at this point of time, we are mostly using for making these two techniques are mainly used for making models or prototypes. For manufacturing of our final product, still it requires certain aspects to be addressed, that is mechanical behavior prediction. So now coming to this point, the third type of additive manufacturing technique, focusing SLM, we have one thing, that is post processing. For post processing, heat treatment is the common process which is generally used for conventionally manufactured product also. So the same is used here also to enhance the mechanical property. And it has been noted and it has been observed by several literature also that heat treatment controls the mechanical behavior of powder based printing, behavior of parts made through powder based printing method. Now the thing is, the thing which is to be highlighted here again, that heat treatment controls the tensile and fatigue both. However, if we see the tensile and fatigue behavior after the heat treatment, significantly it has been reported in several literature that it has been significantly changed. Now the literature are still limited, and the heat treatment, the range of heat treatment or the process of heat treatment also play a major role. So considering the role of heat treatment on this particular type of manufacturing technique, I have conducted the study, and that study is based on effect of, or the role of heat treatment on the fatigue behavior of SLM printed stainless steel material. So that will be the part 2. Now coming to the motivation, as said, that for effective design and analysis of the part subject to different loads, mechanical behavior of the part should be accurately captured. So for capturing the mechanical behavior, we can conduct experiment as well as numerical model. But fabrication of such part, still I told you that SLM printed material or SLM printed parts are very costly. So numerical modeling will be the tool to help us reduce the cost. Now, a few areas and application of mechanics I've included here, that how applied mechanics is, how a department of applied mechanics helped me in exploring the other areas of mechanics, where additive manufacturing, biomechanics, battery modeling, material modeling, modeling of composites, all these fields are being explored by me. And I have projects from all these fields. A project from all these fields, and the basic thing is mechanics is applied everywhere. Now you can see one of the field according to your expertise, whichever expertise or whichever field you want to apply your expertise, considering mechanics. So it is up to you, you can decide. Now, a few other results of modeling of 3D printed parts I have included, that how it was my tensile test. I have covered the tensile, fatigue, numerical modeling, experimental studies on the orientation of the rasters. That is all covered in my studies. However, I have included few results. Now, WHT and HT means without heat treated and heat treated specimens. So specifically, I wanted to enhance the strength of material. And conventionally made material, and if we compare the strength of conventionally made material and 3D printed material, they lags in strength. So if we can use some heat treatment or some post processing by which we can improve the strength, then we should try that. And with that aim, I started experimenting. And these are the few outcomes of those studies. For 0 degree and 45 and 90 degree orientation, I hope you all know that 0 degree means along the length. If we are using a 0 degree orientation, raster orientation, it means the scanning. If it is, this is plastic, okay, I have not included, this is FDM product, this is SLM product. So FDM, this is FDM product and this is SLM product. FDM, if we can see, there is a visible, it is clearly visible that 45 degree orientation of the fiber is there. Now, for modeling of such part, we can use analytical modeling considering transversely isotropic composite theory. So this particular sample was modeled. It was tested experimentally and then modeled analytically using classical laminate theory and modified classical laminate theory. So the results or the discussion is included in one of the book chapter which has been already there, is published. So modified classical laminate theory and classical laminate theory was used to model the or to capture the tensile behavior of these specimens, which was printed using FDM technique. That is fused deposition modeling. Then now for modeling of these particular samples, I used transversely isotropic, that is transversely isotropic material modeling method or approach, which is which actually require reduced parameter estimation instead of considering the orthotropic material modeling approach. Now, while modeling SLM part, if it can be modeled, as you can see, there are no lines or there are no rasters which are visible. Because the laser here, the laser which is used produces a very fine product, which has a, I think what I have noticed, it has a surface roughness of around 3 micrometer, less than 3 micrometer. If it is produced roughly, Now, for further finish or more fine finish, we can get a product of around 1 micrometer surface finish also. That is RA 1 micrometer. Now, for tensile specimen, RA 1 micrometer is okay, but for fatigue specimen, we require surface roughness with RA equals to 0.5 micrometer. So, if we see that if we compare the FDM products and the SLM product, we can, what I have done is I have modeled using isotropic, kinematic. I have used isotropic, kinematic, and combined hardening model. It means instead of using transversely isotropic model, I have used isotropic hardening model, kinematic hardening model, or combined hardening model. All three models separately studied. However, I have included combined hardening model here in my studies. This is my ongoing under review funded projects. As we have seen, as it has been explained in the introduction, that I am currently running some projects also. Most of these projects deals with composites, finite element analysis. Then I'm taking some industry projects also, wherein I am teaching that is design of advanced shock absorbers. I'm teaching finite element analysis to industries here. That is Munjal Shova Limited in Gurgaon. Then we have computational modeling for design of insensitive munitions to mitigate sympathetic means. This is a DRDO project wherein mechanics of this particular detonation process is being done, or this explosive warheads has been studied. Then there are other mechanics of bones. So I'm using mechanics of bones. The experimental part is done by one of my that is the PI, Dr. Abhishek Tiwari, and I do the modeling process. So battery module housing, as we can see that I have projects, and it is recommended also by the committee. The only thing is okay, this is ANRF, it is under review. There is NRB project which I have not included. So these are my current projects which are undergoing. There are two under review. One is submitted, that is one I've excluded, that is project 9. It has already approved, but forgot to include, no problem. Okay, coming to the part 2, that is experimental and numerical modeling. So let us see. If we see that additive manufacturing as a solution to conventional manufacturing approach, the thing is all these aspects are very important. That is the complex geometries, material efficiency, tooling and setup cost, customization, reduced lead times, and the supply chain dependence, labor cost, tooling and process flexibility. All these aspects have to be looked at if we are trying to if we are introducing additive manufacturing in assembly line, or if some part is to be manufactured through additive manufacturing route instead of conventional manufacturing route. So these are few aspects which have to be looked at. Now, as far as literature's findings are there, it is seen that SLM is good for complex manufacturing, complex geometries, material efficiency also. SLM is good. Tooling and setup cost is slightly downside. Customization, it is good. Reduced lead time, compared to FDM and all. If we should not compare SLM with FDM. So again, it is balanced. This kind of analysis has been done in one of my work, which I am trying to show it to you. Then supply chain dependence, because we require powder in this particular technique. So supply chain dependence is high. Then it is a negative point. So I call it as a negative point. Lower labor cost, again, it's a negative point. So I'll consider this. Arrow up is positive. Then tooling and process flexibility is this. Now, if we consider the positives, we have 1, 2, 3, and 4 positives and 4 negatives. Now, we need to choose SLM if complex geometries and material efficiency is very important for us. And that is why still, although it has several negatives, SLM is gaining popularity day by day because of these two features. There are several other features. However, these two features also primarily govern the choice of the process for making metal, additively manufactured metal parts. Now, this section will cover the fatigue behavior of parts fabricated by SLM printing, widely used for metal part fabrication. Considering the importance and significance of SLM process, that is selective laser melting process, I have chosen this particular process for making the part and to carry out the fatigue study. Now, fatigue is a major, load. Major failure causing load for parts or components in moving application or in movement, or whenever there is a relative motion, or the or machines which undergo undergo cyclic loading. Fatigue is the major load which actually governs the failure. So I've tried to model fatigue behavior and included this in particular presentation. The SLM is a powder-based printing, as said. Now, if we see fatigue is the cyclic loading, just for introduction and for the sake of the completeness, I want to give a brief about fatigue. That is, it's a cyclic loading in the material such that localized stress that leads to crack initiation, growth, and final fracture. It has two types, mainly SCF and LCF. The current studies focused on LCF, which is a critical aspect in assessing the mechanical integrity of materials under cyclic loading conditions. And if we see the LCF or SCF, both can be strain controlled or stress controlled. That is, if it is stress controlled, then commonly known mode of failure is ratcheting. That is ratcheting. That is again a mode of failure. Now, if it is stress controlled, the common mode of failure is ratcheting. Stress controlled. Now, ratcheting again, if it is extended beyond certain load, if it is extended beyond certain number of cycle, again it reduces to HCF. That is, ratcheting finally leads to high cycle fatigue failure. Now, if we consider this particular portion only, the ratcheting failure is actually it is a partial failure, which is actually leads to accumulation of strain. That is strain accumulation. Let us see this. If we plot Let us try to understand ratcheting and fatigue. Now, if we plot strain versus time plot, now cycle by cycle, if there is an accumulation of strain, now the accumulation of strain actually saturates. Up to this, if we see, this is actually a portion of ratcheting, and this is actually again a portion of fatigue. So ratcheting associated with fatigue, or we can also say there is an interaction of ratcheting and fatigue. So fatigue and ratcheting interaction studies are also there. But if we segregate the effect, the accumulation of strain cycle by cycle is ratcheting. And that we can see when we perform stress controlled loading. So whenever we perform numerical loading, we need to consider the type of loading which we require to model. So stress control loading, it means the boundary condition should be given in such a way such that the stress is controlled within a limit. So this is the load response. Suppose this is load versus time plot, the loading should be like this if it is cycling. And this load can be stress or strain. So if it is stress, we can see this response. If it is strain, we can see another response, that is stress hardening. Let me draw it somewhere else. If the presentation looks clumsy, please let me know. Now, if we see the load is like this. Now we can see this is strain control load. Strain is limited. Now, if the strain is limited, we call it as a strain control load. If the stress is limited, we call it as a stress control load. Now, when we see strain control load, when we apply strain control loading, it means it's a typical case of fatigue. We will not be able to see the ratcheting in this case. However, when we apply stress control load, we can see ratcheting also, and thereafter fatigue. So the current study actually covers the low cycle fatigue, wherein the strain is slightly higher than the yield strength. That is why the number of cycle which is required to cause failure will be less than 10 to the power 5 cycle. And then the material which is used for the current study, which I have included in this FDP, is the stainless steel, that is 316L, which is a low carbon steel, and it is commonly utilized. Why? One more thing, there is a constraints for us also. I could not use the other, that is, I was trying to use SL31 stainless steel 316LN, but the SLM which is available at my place. At my place, it means which is one of my consultant is there in Rajasthan who has made this part. So they are having SLM, which is mainly used for stainless steel 316L. So they may require some parameter changes, or there are specific means the cost will change and the parameter will change, and they do not have that expertise to change the parameters according to SL316LN. So I used this SS316L material for the study, and it is a common industrial steel. So it justifies the choice of this steel also. Now the composition as shown here, this is for reference. If someone wants to use it, they can use it. The specifications and the results are also published in engineering failure analysis. Now, before we again enter into the results and outcome of the findings, let us understand what is selective laser melting briefly. It is like a powder. If you see, powder is there, and this is all the powder, and between that powder there is a part, this part, hexagonal part, if you can see that this is the laser. And one more thing, this is not a continuous laser. It appears continuous, however it's a pulsed laser. It's a very high energy density pulse laser, and most of the YouTube videos you can see that there is a pulsating kind of light, and pulsating kind of light with very high specific energy is used, and which collides with the powder and it melts. And as soon as the path is traced, and the desired layer is made, the platform is actually lowered. Once the platform is lowered, then the leveling roller will again supply the powder to this particular section. So if we see the advanced form of additive manufacturing, it's an advanced form of additive manufacturing which uses a high powered laser to selectively melt and fuse fine metal powders to create 3D parts layer by layer. It is one of the common technique used in metal 3D printing, specifically for application requiring high precision, complex geometries, and high material strength. So we have comparable material strength when we make parts using this particular method. Of course, this is for special purpose manufacturing. It means we cannot go for large number of large number of part fabrication. Bulk manufacturing cannot be, it's not suitable to use it for bulk manufacturing. Okay, now coming to the part fabricated by SLM, which I have used in my study. It is again, I've considered the sample. It's a tensile, which is a fatigue sample. And if we see, there are two ways of making such sample. Like this is build direction and layer direction, layer addition. Now here also the layer addition is like this. That is, we keep on adding this, and once the layer is made, first layer is made, over which the another layer is made. So when the loading direction is this, build direction is this, we can get sample like this. So what I have used is this one in my study, and this particular sample is made up of as per ASTM E606. So ASTM E606 is used for strain control loading, strain control fatigue loading. Now build orientation, as this sentence says, it has a strong influence on the static and dynamic mechanical properties of SLM steels. Regardless of their building direction, the majority of SLM specimens showed inferior fatigue characteristics in comparison to their wrought counterparts. However, there are post heat treatment, post processing, which actually improves the fatigue characteristics. Now, one more thing. Nowadays, SLM specimens, nowadays the SLM has been advanced, and we are getting superior characteristics of fatigue specimens, or superior characteristics of parts under fatigue loading. So there are several literatures also which has established this fact, and my literature also concur with their findings. So okay, till now, is there any doubt or confusion? If you can, if you have, you can ask. If there is no doubt, I can move forward. Okay. Now,
परमिशन ready हो, मुझे गर्मी लग रही, पंखा नहीं चलाना।
Okay, someone has unmuted. You can mute yourself. If there is any doubt, please let me know. Otherwise, I'll move. Yeah. Any doubt? Queries? Okay. I presume there are no queries. I hope I am audible to all.
Yes, sir, you are audible.
Okay. Now, if we see that the parameters which was used for fabrication of this particular, how much time I have?
Sir, maximum 50 minutes you can complete.
Okay, we have another 15 minutes.
15 to 20 minutes maximum. Right, we can start. After that, we will start the question answer session.
Okay. So if we see these are the parameters of the SLM which was used, as I've highlighted here. The surface roughness is 0.5 micrometer for the fatigue specimen. Now, experimental details, if we see, the gauge length is 14 mm, diameter is 6, and the LCF test is conducted at LCF machine, IT Ropar. Actually, the machine at NIT Allahabad is down due to some issues with the controller. Then it is a stress ratio, it's rather strain ratio. It's a strain ratio. R equals to 1 minus 1. And the LCF tests were fully reversible. Okay, the LCF tests were fully reversible. Heat treatment was done at 1050 degrees Celsius, followed by furnace cooling of 70 minutes. The other LCF parameters are listed here. Now, these are the tested samples. After the test, we can see there is a crack formation. Here it is highlighted. Now, WHT is for without heat treated and HT is for heat treated specimen. These are the samples of the fractured specimen. Then this is SEM and the loading of SEM sample for factography. This is done here. And after LCF test, as per ASTM E606, the specimen were forced separated by simple tensile load. It means we should not run the test for complete failure under fatigue loading. So that's why it was cycled for certain cycles, and then just before failure, we need to take it out. Then sample for SEM is prepared. Now this slide includes numerical modeling, that is finite element modeling. It was done in Abacus, and the loading is this one, the red color, that is this. If you see, this is the strain control load, plus minus 0.4, and the sample or the model which is used, actually it is of gauge section of diameter. Okay, it is 5 mm and 12.5 mm. The sample was mistakenly, I think there is some mistake in this. This was 6 mm and the other was 14 mm, I think. I have written somewhere. Okay. Well, I considered only the length of the gauge section only for modeling it in Abacus. The data which is written is slightly, it's a typographical error. Then I've considered hexahedral element shape and swept meshing technique for linear 8-node break element of C3D8R element type. Now, the modeling is done using combined hardening model. Now, if we see cycle 1, half cycle, then we have a stabilized cycle, then failure cycle. So at failure, a cusp has been observed. This The cusp in the curve actually tells that the fatigue crack initiation has taken place and we need to take the sample out. So numerically also it is very well predicting, and this is for HT and WHT specimen predicted experimentally. Numerically, if we want to predict this cusp, it is very difficult. So what we do is, in numerical modeling, we only consider the stabilized cycle. Up to stabilized cycle, and thereafter we apply the cycle. And for modeling in Abacus, we can import the cyclic results in other softwares. So I have included up to modeling of the fatigue behavior up to stabilized cycle. Now these are experimental results wherein the peak stress for WHT, that is without heat treated and heat treated specimens, have been included here. We see that the peak stress, initial peak stress, is very high for WHT. WHT initial peak stress is very high, and for heat treated specimen the peak stress is less. It means once the peak stress is very high, it means it has its load bearing capacity is significantly reduced in first few cycles only. Now the peak stress is very less indicates that its load bearing capacity is not at all expanded up to this also. If we see that up to 1000 cycle, the peak stress variation is very less. And once the peak stress variation, if one more thing, this graph also tells us that peak stress is reducing with number of cycles. The other thing is we have compared Young's modulus also. Young's modulus slightly more for WHT. Instead of what we were expecting, that we'll get Young's modulus more for HT. Now this is the case where we are actually focusing our further studies also. So why we have Young's modulus greater for without heat treated and lesser for heat treated, although fatigue life is more. So the reason which we have obtained so far is that microstructural coarsening can be the possible reason. However, it requires substantiation further. So certain other tests are going on in my group. So my group is carrying out certain other tests which require further validation of this particular results. Then plastic strain energy with number of cycles is shown here for heat treated and W heat treated without heat treated samples. And we noticed that strain energy, plastic strain energy is reducing with after large number of load cycle. It means it is losing its load bearing capability slowly. However, without heat treated sample is losing its load bearing capacity, that is cyclic load bearing capacity, at a faster rate. So this plastic strain energy variation with number of cycle, this plot particularly gives us this information. Then we have carried out MVH test also, wherein we have noticed that the hardness was found to be lower for heat treated specimen than that of W without heat treated specimen, both before and after the fatigue testing, which can be attributed, of course, to the residual stress reduction, which is in concurrence to the arguments of heat treatment induced hardening. So this is in concurrence with the existing knowledge also. Now, here we have again compared the peak stress. It's a slightly zoomed view of earlier plot, that is peak stress variation with number of cycle, wherein the number of cycles are in log, log cycles. Here, this particular information is used to cover degree of softening, that is degree of softening. If degree of softening is less than 12%, it is less than 12%. It is, and in case of HT specimen, it is high. And for without heat treated specimen, the degree of softening is more. Now, degree of softening, if it is more, it means the fatigue life is less. This is also as per the literature which is available, which is published. And the relation of degree of softening with strength is already established, and the same which we have observed for this particular test also. Then we have carried out the fractography and fatigue failure analysis, wherein some unfused material in WHT, we see that there are more unfused material. However, after heat treatment, unfused material are less, and this is again, it concur with the existing knowledge also, that heat treatment actually reduce the unfused material. Although this is a powder bed fusion technique, so we actually require heat treatment. Then several other information where we have noticed in the scanning electron microscopy and optical microscopy also has been done. This is just to correlate the findings of the fatigue failure analysis, wherein we have seen striations, pores, unfused material. Here the unfused material, number of striations are differing. Now, crack initiation in this particular heat treatment, we see that intermediary or what we call as crack branches are seen here. However, at the surface also we can see, and for WHT specimen, we can see cracks at exterior part of the part. However, internal cracks are seen in heat treatment products, heat treatment part. These internal cracks are of very less dimension, that is, we call it as micro cracks. Then again, striations are visible in this particular plot also. All these striations, we can see these striations. Then we have cleavage facets. The presence of cleavage facets gives us information that the fracture of these particular samples are exhibiting ductile nature. It means a ductile fracture is seen. Now, more cleavage facets, you can see striation marks, tear ridges, and the developed micro cracks. All these are available. Cleavage facets in the WHT and HT specimen indicate region of brittle fracture, which could be due to the martensitic transformation. Then the number of microvoids and unfused materials are more in WHT specimen than in the HT specimen. This indicated densification and homogenization in heat treated specimen, which actually improved the fatigue life. So this actually, the aim of this analysis is to correlate the findings of the numerical and experimental analysis with the fractography. So this again consolidates our findings. Then we have few initial defects such as micropores in heat treated specimen, which would have resulted in fewer cleavage facets or brittle fracture regions. Now, relatively large number of cleavage facets in without heat treated specimens are observed compared to HT specimen, because brittle fracture is characterized by both cleavage facets and intergranular mode of fracture. So fatigue, after fatigue, both are exhibiting actually the ductile fracture, but large number of cleavage facets in WHT specimen is seen compared to HT specimen. Then the other finding is annealing heat treatment was performed on the 3D printed specimen. The initial defects concentration found to be reduced significantly. Now, the results of numerical modeling is added here, wherein I have used combined hardening Sabochet model of Abacus, wherein the parameters are identified by trial and error method, by tracing the first cycle and then running it for the cycles such that the strain or stress is stabilized. So the for 20 cycle is model, and it is shown here. Now, once cyclic modeling is done, this is done to calibrate the model and get the optimized parameter for cyclic hardening. Now, once the cyclic hardening is traced, then I have carried out the test for stress cycle. That is, stress is actually tracing the perfect stress versus cycle number plot. Now, if we see the for tensile, numerical tensile, experimental compressive, numerical compressive, it means the compressive and tensile stress at each cycle, the positive and negative cycle, the maximum values are traced, and it is actually tracing. The numerical and experimental curve are actually matching satisfactorily. For both WHT and HT specimen for 20 cycle, I have carried out, and the parameters are identified. That has been published also. So we can actually model the fatigue behavior using abacus, particularly for SLM, because SLM slightly it resembles with the conventionally manufactured part. The parts which are manufactured through SLM are nearly equal to conventionally manufactured part. So that is why it has been used, this particular model, Sabochet model, which is widely used for metal, has been implemented in abacus for modeling this particular 3D printed part instead of composite approach. However, for FDM, we should not use Sabochet modeling. For FDM, we should use composite approach only, and that has also been published in one of my literature. Now, both in tensile and compressive modes, due to symmetrical load, the specimen exhibited similar behavior. Figure shows with rapid initial softening followed by a region of slower or nearly saturated conditions that prevailed after 20 cycles. It is observed that peak stress values with cycles are higher for WHT than for HT specimen. This has led to the rapid damage accumulation in WHT compared to HT. Now, important takeaways, if we see the heat-treated specimens, now this is the last part and the conclusion, if we see that HT specimen have exhibited 62% higher fatigue life compared to WHT specimen, while the WHT specimens have higher peak stress than HT specimen, indicating heat treatment induced softening in HT specimen for the initial few cycles. Then the second takeaway is the energy observing capacity is enhanced after the heat treatment of SLM part. Also, the SLM printed SS316L exhibited in reduced Young's modulus after heat treatment, which suggests that tensile strength is decreased by heat treatment. This is particularly for this study. However, this requires further consolidation because the reason for microstructural coarsening or microstructural refinement is still not very clear. Why such kind of thing is happening, and that is again a part of a study which is carried out here. Then degree of shortening was found to be lower for HT specimen compared to WHT specimen, which exhibited around 25.3% degree of softening. In most of the engineering application, the early stabilization of cyclic behavior is desired to prevent cyclic strain accumulation. Thus, the progressive damage due to cyclic strain is negligible for HT specimen. Progressive damage means, again, that is ratcheting. It is the cyclic strain accumulation is negligible for HT specimen. Consequently, increase in fatigue life is observed. So, very less amount of ratcheting is seen in HT specimen. Then the last few points are micro hardness values that was observed. That is, if we see before and after fatigue, 176, 169 hardness values for WHT, and while it is 238 and 223 hardness value is observed for HT specimen. This indicates the increase in hardness after fatigue test, while vice versa is observed post heat treatment. Then there was improved fusion of the material in heat treated specimen compared to without heat treated specimen. We have micro cracks also generated from the surface, propagated and led to fractures, while many micro cracks that are not fully developed have been observed in the HT specimen. These are internal actually. So because of these internal micro cracks, maybe it require consolidated or consolidation of the findings, because there are several micro cracks which were present, but it was internal micro cracks, which may again refuse to, it may get repaired also. Now, WHT specimen, the number of voids found in HT specimen is less than that found in WHT specimen. HT again heat treated, and WHT means without heat treated. For the same fracture region, more striations in heat treated specimens are observed. So striations are more compared to WHT. This also supports the argument for increased fatigue life. So striations are more in HT specimen, which again supports the increased fatigue life of HT specimen compared to WHT specimen. That's all from my side. Thank you. Happy researching. Now I'm asking queries and doubts. If you have, I can again come back to that.
Thank you, sir.
Thank you all. Yes, sir.
Hello, sir.
So anyone? Yes, yes.
Myself, Dr. Manish.
Yes.
Be ready, sir. Okay. Working in CPET Jaipur. Sir, as you have discussed a lot regarding the powder bed system.
Yes, yes, yes.
So what we find that the powder are not found in a particular size particle. It is found in a distribution.
Yes, yes, yes.
How it play a role in the like a finishing, mechanical property, and all other.
Okay, okay. See, it is again a very difficult part to ensure the powder size which is being used to manufacture such kind of products. Now there is a range of powder size, as we have. Let me show you the slide. Powder size is 50 micrometer. So I have used it. It's a single value. However, there is again distribution of such kind of powder sizes. So instead of using a fixed powder size, I should have used the standard deviation. The standard deviation should be very less. And it is very difficult to get powder of uniform size from any powder metallurgy method. So what we need to segregate powders according to particular machine and specification. We need to segregate the powder size, and within that specified range for a particular machine. Like Renishaw AM400 machine, it is suitable for manufacturing of parts with 50 micrometer and plus minus some tolerance. That information must be available with the manufacturer or the fabricator. But as of now, I can say that yes, powder size, maintaining a fixed powder size is a very difficult task. And there are a lot of things which needs to be done to maintain such kind of powder size. And it will affect the quality of the product. I hope I have answered.
Hello, sir. One more question.
Yes, sir.
Sir, have you studied regarding the effect of asperity, powder asperity?
No, no, no. That I have not. Actually, this powder, I got this printed part. My focus was to carry out fatigue test of the SLM printed parts, and powder asperities, powder sizes, and all. The supplier of the part. It was at their end. So I've not got into that much detail. Of course, there is a effect of these parameters. I told you that there are several other parameters which governs this. Like laser power, it is mentioned 200 watt, but there are laser time also. That is duration of the pulses. So all these effects. Scanning speed is one thing. Then duration of the pulse, energy of single pulse. So there are several other parameters which also affects. Now, macroscopically, now this is a macroscopic approach. What I have done is a macroscopic approach. At micro level, there are several other parameters which will be playing their role.
Thank you, sir. Sir, I request to please share the slide with all of us to participate.
Yeah, it has already been forwarded to the coordinator of the FDP. I think Dr. Zubairuddin has already having, I think. So it can be distributed to you all.
Okay, thank you, sir.
Thank you.
Sir, excuse me.
Yes, sir.
Sir, my name is Dr. Muhammad Hassan.
Okay, okay, sir.
Sir, may I know that what would be the minimum specimen size of the people we can prepare on this machine, and what would be the maximum size we can prepare?
Regarding SLM printing?
Yes, sir. Yes, sir.
Renishaw AM400 machine, if you see the specification, as of now, I do not have any information of Renishaw AM400 machine because this is again at the supplier end. So I gave the sample, you give the sample size as per the STM standard, they'll make it. So if you see the brochure of Renishaw AM400 machine, it is already clear. It is available in internet also. It's a open source PDF available in internet.
Okay, whatever sizes we need, we can make it.
There must be a size limit also. There must be a size
Yeah,
limit.
That what I want to know. What will be the minimum and maximum?
There must be a size limit which I can search and give it to you, or you can
Okay.
I'll download it and
Okay, okay, sir. Sure, sir. Okay, if it will be possible, sir, please. If it is.
Yes, sure, sir.
Okay, sir.
Anything else?
Other, you have used SS 316 now, sir.
Yes,
other possibility, other materials also are possibilities are there, now, sir. On this machine, AM 400 machine.
Yes, sir. There are several others.
Is there any other materials or limited materials are there?
The problem with the supplier means the person which actually supplies these parts to me, they do not have expertise to change the parameter of the machine for different materials. Although the capability of machine is there, means we have one machine at IT Ropad also. So again, I told you that there is a problem of expertise. They do not know at what power or what would be the laser pulses. The parameter changes with the material change. So more of the people are they have got the expertise or learned or developed the expertise to deal with SS316L. That is why I have considered also, because it is widely used steel. For other materials like titanium also, we have some supplier at in Bangalore. So they also supply titanium alloys also. So there are several sources which have developed their expertise in fabricating different materials.
Okay, sir. Okay. Thank you, sir. Thank you for your kind information.
Thank you, sir. Thank you, sir. So I may leave now.
Yes, 1 minute. I hope everyone clear about the question answers. Any other questions are there? Yeah, I hope no one is having any questions. So we can move to the vote of thanks. Dr. Ujjal.
Sir, thank you, sir. Thank you so much for your valuable time on additive manufacturing. All you have given a lot of inputs regarding SLS machine and parameters, everything. And participants also got a lot of input points which they can do for further research also. And once again, thank you from our Aditya University, entire Aditya University and management for giving your valuable time for this entire session, sir. Thank you, sir. Thank you, Mr. Sir.
Thank you, sir. Thank you. Thank you, sir.
Now we can go for the second session. I will share. The second session speaker, Mr. Syed Abrar Hussein, Senior AI Manager. We are delighted to welcome Syed Abrar Husseini as a distinguished speaker for the AICTA ATAL Online FDP on AI and simulations in additive manufacturing. Syed Abrar Husseini is a senior manager, AI leader, and AI architect with over 14 years of experience in artificial intelligence and management consulting. He specializes in leading large teams and managing end-to-end complex projects from pre-scales to implementation and delivering measurable impact for clients through data, AI, and generative AI. With rich cross-domain expertise, he has worked across multiple industries, including consumer, retail, restaurants, TMT, technology, media and telecom, digital marketing, and financial services and insurance. A passionate AI evangelist, he has organized and led AI summits, recruitment initiatives, innovation programs, learning and development sessions, and team building events at Deloitte, making a significant impact on 5,000 plus colleagues and team members. Beyond AI, he is an avid sports enthusiast, having captained multiple winning teams in football, chess, and cricket at both college and Deloitte. He has also contributed to AI research, co-authoring a paper on attitude risk models in the pharmaceutical sector presented at IIM Ahmedabad Analytics Conference. His educational background becomes from BTech in Electronics and Telecommunications from Maharashtra Institute of Technology and Executive General Management Program he had done from IIM Calcutta. We look forward to an insightful section with him. I welcome Mr. Syed Abrar Hussain, sir. I'm handovering this session to you. Thank you, sir.
Thanks, Pritham, for the warm welcome, and thanks for inviting me for this session and having me here. It's a pleasure on my end to be here. So I'll speak today about AI and GenAI. So let me share my screen and I'll go off. So hopefully you can see me right, but I'll go off video because I'll be presenting the deck. So nice to meet you, everyone. Hope you can see my screen.
Yes, sir.
Right, so today we will be covering three key topics. One is around AI, Gen AI, right? What it is all about, right? So we understand. I'm assuming most of you would have already heard and seen this, but just a quick overview. Then we'll go and understand what are the key players and providers and what are the risks associated with Gen AI. And then we'll deep dive into the applications and how Gen AI is helping transform the world. And I want to keep this session engaging, right? So I'll ask questions. You can ask me questions as well, like quick ones in the middle. So that way it's not one way, but I want you to interact with me, right? And go on in this journey. Hope that's clear. Okay, so we'll start with what is AI, right? So we have all been hearing about AI, right? And how it's going to transform the world, right? It's going to take over the world. We have seen it in movies, we have seen it in our real life. So I wanted to simplify what AI is, right? And what is the hype, what is the reality. So AI is basically what you'll call a simulation of human intelligence. So our brain, right, is a varied network. So the machines using data and computer, they kind of simulate our brain. So you ever have heard of neural networks and similar AI technologies? So that mimics our human brain using data and computer system, because our brain can only capture limited amount of data, whereas computers, they can capture tons and millions of data, right? So it imitates our human behavior. That is AI, right? To keep it simple. And to make it even more simpler, all of you here have read mathematics in school, right? So I'll tell you an equation, right? A simple equation for AI. So if you want to do something, right, that's a functionality, You have to have data. So that's based on data, whatever data you have, your own data, public data, third-party data, right? Publicly available data on the internet in order to do something for the customer or for the business, right? So if you want to build a better product or you want to do some sort of communication, right, and improve your business, that is what it is in a simple terminology. Is that clear? It's like I wanted to make it very simple, right? So do something based on data in order to achieve something, right? That is a simple equation you can remember about AI. So talking about Gen AI now, right? So, and yeah, just before that, so in terms of AI, there are like, you would have heard about data science, you would have heard about machine learning, AI, Gen AI, right? All of these are similar technologies, right? There are levels like data science, machine learning, as you can see on the screen. There are different ways you can think about, like 6th standard versus 8th standard versus 10th versus 12th, right? If you think about that way, so data science, machine learning, AI, then Gen AI. These are the levels within the whole AI space. So some people call it data science, some call it machine learning. It's all based on statistics, mathematics, so and using computers, right? So this is all the same. So you will hear multiple terms around this. So generative AI, right? So before I jump into this, how many of you have used ChatGPT? Can you raise hands or can you just call it out, right? ChatGPT. How many of you have used
Yes,
ChatGPT?
I've used.
I think most of you would have used, right? ChatGPT is in the news. Here it's on WhatsApp also we have a version called Meta AI. It all uses LLMs and similar technology, generative AI. Can someone tell me the full form of GPT? Most of you have raised your hands. Can you tell me the full form of GPT? You have used ChatGPT, right? So tell me the full form of GPT. Ping it on the screen, on the chat window, or just tell orally without Googling. Okay. So can anyone tell me the full form of GPT? Anyone? You have used ChatGPT, right? So do you know what is the full form? Okay. At least tell me, when was it launched? Simpler question. When was ChatGPT launched? Come on, I want to keep it engaging. When was ChatGPT launched, or when did you start using it?
2021.
Any other thoughts? Any other answers? Look, it's all fun, right?
Around
Like, just want to
2022.
ensure. Yeah, it was end of 2022, right? When it was created. And then people started using it mostly in 2023 and 2024, right? But do you know when exactly Gen AI or all these similar type of applications were done? It goes way back in 1940s when Alan Turing, right? He is also called like the guru or father of computer science, right? He had created something similar using analog computers back in those days to kind of crack the cipher code during World War, right? So all these AI, Gen AI, this all goes way back, right? From 1940s onwards, and then you can see the first chatbot was created in 1964. Then we had a Deep Blue IBM machine that defeated the world champion Gary Kasparov, right? So that is how all of these systems evolved. And now we have ChatGPT, we have now Meta AI, now we have DeepSeek. You would have seen DeepSeek coming in, right? So all of these things are there. So all of these things have been from a period of time, they have been evolving, and now we have been able to see those in reality. Okay, so it's all not new. It has been there for long, but now it's getting wide and broader into the mainstream. So if I try to decode, right, why this has happened. So we had assistant human intelligence, then we had augmented, and now we have autonomous. So The autonomous one is where we are right now here on horizon 3. So you would have seen self-driving cars, Tesla is there, now BYD and others. Now you have drones, you have smart robots, right? So all of this is falling under autonomous intelligence. And there are four key factors why there is this big boom, right, about AI and Gen AI, and everyone is talking about it, right? NVIDIA is like the number one in the market, and all the tech stock and everything is going up, right? Is because of this AI and Gen AI boom. So there are four key factors why it has happened. One is the data. Now we have so much data because of social media, right? And all the devices being connected, it captures everything. You have your apps that capture everything. You have videos that are being recorded, photos being published, text being written. So all of that is the explosion of data. So all of that data is being captured properly. Okay. The other one is the computing power. So with NVIDIA, why NVIDIA became number one, right? Because of their chips, the GPU. So earlier in the day, when you used to play video games, NVIDIA used to have graphic processing unit, right? That was for graphics of the game. So using that, they also built better versions of GPUs for compute. So that way all this data, right, that has been captured can be processed faster, right? So instead of like taking months and days and weeks, now it within seconds and the data is being processed and you get answers. Number three is algorithms. So now with open source being there, sorry, any questions?
Sir, we couldn't see your screen.
Is everyone not able to see or only a few people? Can others see my screen?
It is visible.
It is visible, right? Okay. I think people might have joined late or maybe try joining back again. Okay. Hope everyone is able to see, right? So I was saying sophisticated algorithms is the other reason. So we have PhD people who are giving open source algorithms. So those are packages and libraries being created that are being then used by everyone. So it's not paid, right? It's free, it's open. So companies, researchers, people who want to build something, right? They are using these sophisticated packages and algorithms to build new things. And then finally, it's about all intelligent human machine interactions. So as the machines are getting intelligent, the humans are also leveraging machines in the right way to build these products. So it's a collaboration between humans and machines, right? So people say, okay, machines will take over the world, right? They will take over your jobs. But I would say that people who are using AI will be the ones who will take the jobs if you are not using AI, right? So you need to learn on some of these things on how you can get yourself better and more efficient. So earlier when there were no computers, computers came in, people said computers will take the jobs, but it created more jobs for people who learned computers and were able to use it properly. So same way, if you are able to learn what is AI, Gen AI, right, and use it, you will be in demand, right? So that is that intelligent human machine interaction we need to do. This is what I was generally talking about, right? So you have the compute power, you have the data, you have the models, you have the prediction, and what you then see. So it's more like that iceberg. So people have seen Titanic, right? Or I've heard about Titanic. There was an iceberg, right? Which was pretty big. So this is similar in that sense, right? But you can only see the top portion of it, which is the generative AI application like ChatGPT or Meta AI, right? And other DeepSeek and others. But to build all of that, you need to have a strong infrastructure, you need to have a platform, data platform, and then you have to have the models. Only then will you be able to do this. Okay, and there will be some words you would have hearing: prompt engineering, tokenization, parameters, transformers, right? So all of these are the key terms that are being used for generative AI. Any questions here, or let me know, right? If you have any comment. So where is generative AI the most important, right? These are some of the classic use cases where you can use generative AI to the best of your ability, right? And utilize it fully. So summarization. So if there are big documents, right? There are books, there are audit pages, there are so many, like we are been all part of our school life, college life, we have 1,000-page books. But imagine if someone is able to read it in seconds and tell you the summary of it, right? How useful will that be, right? Instead of going through all 1,000 pages, which will take days and months, right? Within seconds, it's able to read through the entire book and tell you what are the key themes of the book, what are the key things that you need to learn, right? What are the key topics and things around it. So that is where generative AI can do it in seconds. Q&A, chatbots, right? So if there are anything you need to know, it can go and understand through the entire repository and tell you an answer. So you don't need to now Google, right? You can just ask the same thing and it will directly give you an answer. So earlier when you used to Google, you have to then give options, then you select, it used to take many minutes and seconds. Now within microseconds, you get answer, right? You just ask a question, it will give you an answer. Then there are like different transformation, like for example, coding especially in IT and other, coding is one of the key important things. So it's able to now create codes very easily. It can convert codes from earlier languages, say MATLAB was there, right? From MATLAB to Python, it can easily create. From SQL to some other language, right? It can easily create new codes or convert codes for you. And obviously it's not 100%, but you need to, it will do 90% of your job, right? And you just need to make minor changes. So a lot of this content generation, image generation, you would have seen now videos being created, small movies being created, right? Images being created. So a lot of fake images are also being created. Obviously that is one of the disadvantages we'll talk about later. But those are the things that GenAI is really, really powerful. And you need to understand how you can use this to make your life easy, right? So you have to work smarter, right? And not harder, to make it in one simple line. So we have been talking about all GenAI, right? But these are some of the important vendors or key LLM providers. So Alphabet, right? Google. So Google has been one of the key providers. OpenAI, Microsoft, right? They have been collaborating to get all the ChatGPT. So ChatGPT is built by OpenAI, which has been funded by Microsoft. Amazon now has its own models, right? Bedrock and Anthropic is being, they've been tying up. Google has Gemini. Nvidia has their own models, Megatron and others. You would have heard about DeepSeek, how DeepSeek came in and the stock market crashed for Nvidia and all Microsoft and others because they were able to build cheaper models. So every company is now trying to build their own LLM or GenAI model, right? So LLM is basically large language model. So they are also building small language models. So all of these are all these GenAI key providers that you need to be aware of, right? And what are they doing? How are they building new products and increasing competition? India also has been trying to build a lot of these LLMs, right? You would have seen Mukesh Ambani talking about how Reliance is trying to invest and create their own. So there are a lot of these things that have been happening, and hopefully soon India will also have their own LLM model. Excuse me. Anyone who is not aware of these or who is aware of something which is not here, feel free to let me know, right? It will help everyone enhance our knowledge. So what benefits, right? We have been talking about using GenAI and how it can help us, right? So these are some of the benefits that are there for you if you start leveraging AI and GenAI. It helps you be more creative, right? Because most of your heavy lifting or tasks that require more of your time, they can be freed up by GenAI. By using GenAI, you can spend more time on doing more creative things, right? For example, as I was telling, right, if there's a book, right, that you need to read, so big book, so you don't need to spend a lot of time. It will easily be done by the GenAI and give you a summary, and then you can do something out of that, right? So same way with like writing emails or say writing a white paper, right? It will help you build the template. It will help you build a story, and you can just go in and make edits, right? And use your creativity to make it better. The second point is increase in efficiency and speed. So you can do things faster, right? So instead of spending 1 hour, you can finish that in 5 minutes and do 5 more things, right? Or do things that interest you the most. Cost is reduced. So a lot of transformations are happening where the cost is being reduced in the back office, right? Or front office, contact centers, because now instead of people being there and say you are stuck somewhere, right? You have a complaint. You are using a product. So what you do, you call the customer care, right? And try to get your answers done. But say 24/7, you have a chat bot, right? Where you can ask a question, it will give you an answer. That saves you time instead of waiting on the call and waiting for the agent to pick up the call. This is 24/7. A company, if you're setting up a business, can use it, right? Or as a uh, college student or something, you can use this pretty effectively to reduce cost. User experience is better. The new products, you can create new innovative products. It can help you with your decision making because all of this time you can utilize better, right? So all of these are the potential benefits more than just cost, right? There are many other such benefits. If you try to leverage it properly, it will help you improve your efficiency and provide value to yourself, right? And to the company that you're working or to the college or wherever, right? To your business. So all of these things will help you a lot. Just try it, right? I'm assuming most of you would have already started leveraging it, but if not, then now is the time. All these tools are new. Most of them are free. You can start leveraging them. So we have been talking a lot about benefits, right? But there are some risks and limitations I want you to be aware of, right? When using generative AI. This is a relatively new tool, right? ChatGPT was what, 2 years back it was launched. Same way, like you have DeepSeek, you would have seen how DeepSeek is not able to answer questions, right? And give wrong answers also for some of them. So there are these kind of 10 things I would like to call out, right? Which you need to be aware of in terms of the limitations and risks. So the first is bias. So a lot of training data is being used, right? So your Wikipedia data or any of your application data, if you're using Facebook is free, right? But it takes your data. Same way with Google, right? Gmail is free, Google Maps is free. All of these applications are mostly free, but they take your data, right? But they give you free service. So they use this data to build models, right? So the LLM model that has been built by ChatGPT, OpenAI, and all of these, they use the data. So this data is the training data, as we call, which sometimes has a bias depending on if they say using only European country, right? And answering questions for Asia. It will give sometimes incorrect answers. It will give biased answers. So we need to be careful of when we are using this, like how is the training data? Sometimes the data is only till say 2023, right? It's not relevant or it's not accurate or up to date. So you need to be aware of some of these things. Other thing is privacy. Because you are sharing data, you need to be aware of, like, if you have the right privacy protocols, you might not want to share your data, right? It's personal information. Why would you like to share your personal information, what you are browsing, what you are doing, right? Where you are going? Why would you want to share it with a company? So we need to be aware of some of these. If you don't want to share, there are options where you can click on some like small button will be there at the end that you don't want to share data or you want to delete some data. So you need to be aware of these rules and terms and conditions, especially. Right. So this is one of the key areas. The other thing is ethical use. So we have seen how like people are getting fraud, right? Like fraudsters are using this to defraud people, loot people, right? Using generative AI tools. So a lot of these things are in the market. You would have heard the stories, you would have seen these being done to some of your friends or people in your network. So these tools are also being used for such fraudulent activities and fake things, right? That you see. So we need to be aware of what is actually real versus what is actually fake. So we need to be really careful on ethical use of some of these things. There are also things like forgery, right? Or even plagiarism. So someone has written a book, but this model is trying to capture some of that information and create it as their own. So a lot of the ethical behavior, ethical use of the tools are things we need to be aware of. Hallucination, right? Sometimes the order, it's not, so let me be clear, right? Gen AI models are not 100% accurate. So whatever you are using on ChatGPT or on Meta AI or any of those tools, it is not 100% accurate. You need to also cross verify some of the information. So it's part of the hallucination, because the model, even if it does not know an answer, it will try to give some answer. So that is something that is still being kind of improved, trying to be improved upon by the companies. But it is one of the things that it's not 100% accurate. So you need to be a bit careful while using it, where you are using it and so on. Right, so cost is also other big factor, right? So there are a lot of these things, malicious behavior, IP protection, right, which plays a role in how you use generative AI technologies. So be aware. It's good to know, right, what are the risks and limitations which you are using it. So there are obviously, for anything, there are pros and cons, right? Advantages and disadvantages. There are more advantages than disadvantages. So you need to be really aware of these things and utilize it to your best. Okay. Anything on this? Like, what are the things, if you can tell me that you have seen yourself, some examples, let me know, right? Based on any of these risks or limitations or any of these things, feel free to ping or tell some scenario or some examples that you have witnessed. I want to make it interactive. I don't want to just keep it one way. So if anyone has any good examples to share, feel free to do that. Okay, moving on to the next one. So when companies build these tools, right? So there are different ways. So if I'm going a bit technical now, right? Earlier I was just talking more about the high level stuff, but I'll go a bit technical and tell you a few things about generative AI solutions, right? So there are some what we call as is models, right? So there are foundation models which have been built by these companies that we were discussing earlier, like Gemini, ChatGPT. So ChatGPT has ChatGPT 3.5, ChatGPT 4.0. So there are newer models being done, right? So all of those, those are called as foundational models, and they are built on publicly available data set. So there are three ways you can actually build yourself. If you are, say, wanting to build a own model, right? Or you want to get into generative AI as a developer, or you want to build something on your own, you need to be aware of these three things, right? Even if you're using it just for your knowledge, it will be really important. So these models, which have been built on billions of data, right? They are called as large language models. So when you try to use those models, for example, ChatGPT, right, or Meta AI, what you do is you ask a question, it goes and pings the server, right, and it calls the API to answer your question. So there is no fine tuning, there is nothing, right? It is just basic. You ask a question, it will give you an answer. So if you are trying to build your own application, a simple generic one that talks about what is the capital of India, right? Or who is the prime minister, or who is the president of USA, for example. So it will give general answers. So the first, this as is open source LLMs, those are very good in terms of general answers. So the level of effort needed to build something is very low, but it can give you very good general answers. If you're building your own business or product, you can try using that. The second option is fine tuning of these models. Some of them are commercial, some of them are open source. So there are even paid models which have been built by these companies to generate money. So by fine tuning, what we mean is we take the model from step one, right? But we also add data of your company. For example, if say you are trying to build an e-commerce company, right? Or a website. So you will have information about your products. You will have information about what services you provide, right? If you're building a consultancy or building some new products or manufacturing any new products. So you want to set up a website, right? So you can use this model, LLM model, and add your data information, right? What products you have, what is the cost of those products, what is the availability of those products, all of the information, description and stuff, you can add to this model and fine tune it. So that way the model will now learn what is data that you have, because that data the model won't have, because it's general model, right? So it won't have specific domain specific data for manufacturing or your own particular company address, so on. So you feed in that data to this model, it will learn and it will utilize this data. And when a customer comes or a whoever, right, is trying to buy some product from you, or you are trying to sell something, it will help you understand that domain specific information, and it will easily build that and give an answer for you, right? But you need to be careful about what training data that you are providing and any kind of data privacy agreements that you have for your services. So this will take some level of effort, like medium level of effort and medium general, because you need to add information about your own product. So it is more domain specific. It is more specific to, say, a company or a organization, right? Because that data might not be publicly available as such. So you feed in that data and the model will learn and it will capture that data and give an answer accordingly. That is the second one, which is more around fine tuning. The third one is building your own model. So the level of effort needed for that is pretty high. You also need like good training environment, you need compute power, you need cost, right? And you need expertise to build this. So it takes a lot of time to build, but it will be very, very specific to you, right? It will be more accurate, it will be more faster, right? And it will also help you uh, fine tune and make it more custom. So you can think of it more like custom built for your thing, but it takes more time for sure to build it. But over a period of time, if you are a big company, for example, Reliance is trying to build their own model, right? It's not taking model from OpenAI, it's planning to build their own model because they have such a big company. They want to keep the data private. They don't want to share that data with OpenAI or Google or anyone else. So such companies build their own model, so the which is more specific to them, and it will be able to keep the data safe for them. So those are the three types generally that we have right now. So just to repeat, right, and summarize, one is just using the applications as is, which is say ChatGPT, for example. Second is make fine tune, so make use the ChatGPT model, but add your own specific information about your company, your organization, your business, right? And it will take that data, understand that data, and it will give you answers as per your specific company. So if you have a company, how many employees, what are the policies, right? Each company or each, say, organization, institution, college will have their own set of policies and rules and stuff. So it will be able to learn that, and you will be able to answer, like it will be able to answer your questions specific to your company. Right now, if you ask ChatGPT about your organization or your college, right? What are the rules in my college? Who are the professors in my college? It will not be able to give an answer. But if you add that information to this model, fine tune it, then it will be able to give you answers specific to your college or your business. That is number two, right? And the third one is a big effort, but it will be your own custom model. The data will be in-house, so it won't be shared outside. So if you have data privacy concerns, if you're building something which is more private, for example, government, right? Governments won't want to share some of their confidential data outside. So that's where you build your own model and you don't utilize OpenAI or ChatGPT or any other tools for that, right? You build your own LLM for that. Hope that's clear. Let me know if any questions on this. Okay, so I'll move on to the actual applications, and many of you might be familiar with this, right? So it's basically a summary of what we have been talking about. So the core four applications, one is on image. So you can do image generation for media, advertising, any designing, right? And stuff. You can use that. text for marketing, sales, support, writing notes, or even writing emails. That's where text is more powerful. Then there is the code, right? Where you can write codes. It will write codes for you, right? It will convert codes for you. It will build applications for you. So GitHub Copilot is one of those, right? There are many other such applications that are there. Same way with other like video, audio, gaming, biology, chemistry, manufacturing, any industry. If you talk about robots, for example, right? They are all utilizing now. Robot is not just robot. It is more a thinking robot, right? It can dance. You would have seen videos where the robot is dancing, where the robot is jumping over obstacles, right? It is delivering things, right? It is understanding things. So all of that is being possible because of generative AI and all these new algorithms and all of these things. So it can speak, right? It can understand what you are telling. Alexa and all, you have been there for long, right? Driverless cars have been there. So all of them are getting better now because of generative AI. Any other examples which is not there on the screen, if you want to call out or you have used, right? So that other people benefit from your knowledge. Please call it out, right? Like, let's make it interactive. And hope this is like, if you want to make it even more simpler, let me know, right? If it is too much technical or there are things you're not able to understand, I can make it even more simpler as well. Just let me know.
How generative AI is useful in handling the traffic signal?
Yes, okay, good question, right? So for traffic, generally what happens, right? You have cars passing around, right? At set intervals of time. So there's sometimes morning there'll be more traffic, evening more traffic, afternoon less traffic, right? There are a lot of things like weekends, less traffic, weekdays, more traffic if it is office going place, or if it is more your parks, gardens, weekend, there will be more traffic. So for traffic generation, we have built, or I have also done some use case where it is able to, based on the data, like the video, it is able to capture information, right? How many cars are passing? It can count the number of cars every second, right? And you can then change and make it more dynamic, right? Adaptive, the traffic signal. So whenever there is a time, peak hours. So if you find one way, like cars are going, right? The other way from say home to office, that route, you will have more cars going. Whereas from office to home in the morning, there will be very less cars in that opposite route. So the traffic signal will be able to understand, like via video, if you put a camera there, it will capture this information. It will understand these patterns, right? And automatically, like you don't need to go and change, right? It will automatically, whenever this it sees the cars increasing, it will have more time for that pathway. The other pathway where the route there are less cars, it will reduce the time, right? And give you more time. So it will be able to understand the whole traffic flow and automatically change that signal timer. So you get more time for the cars to pass where it's a busy route. If there is an accident, right, in manufacturing and other such cases, it is also used for capturing any accidents or preventing any accidents. So if there are say two cars coming on the opposite way, right, it can create a signal, or it can have an alarm, right, where it will blast out an alarm saying, okay, something wrong is happening, right, in the manufacturing plant where there is some issue going to happen. Even the machines. So I'm taking like another example other than traffic, where on a manufacturing plant, if there's a machine, right, and it is about to go bad, right, each machine will have a life cycle. After a few years or few months, it needs maintenance, right, it gets damaged. So using generative AI and video imaging, we can understand when that machine is going to go bad, and instead of waiting for it to go bad and create a maintenance plan, we proactively tell, okay, next week this machine is and it's all probability, right? It's all mathematics and statistics. So it will give you a probability like 80% next week this machine is going to go bad, or 95% this machine is going to go bad, right? So then you can proactively assign supervisors or maintenance people to go and fix the machine before the machine goes bad. Same way with electricity poles, right? If there's no electricity, you know how like everything gets shut down, right? So if you know proactively, like, okay, on the electricity pole, there is an issue where say the pole has got damaged, right? Or the transformer has got damaged or will get damaged because of something. So by video and drones, you can capture that information, process that information and raise an alarm or signal saying that, okay, now this needs to be get fixed. Hope that answers the question.
Okay, sir. Thank you.
Okay, and there are these other use cases that I've been talking about, right? So across all the industries, so consumer is more around how you can target customers, right? How you can create visually appealing content and kiosk, right? For customer service. For energy, resource and industries, this is where most of the manufacturing will happen, right? So as I was talking, automated customer service, assisted incident response, 3D models can be created, right? Simulated models, because all these reservoirs, pipelines and big machines, it cannot be, you cannot just go and work, right? You can create simulations of that and you can work via those images and 3D models on how you can build those models or make it better. Same way with financial services, where you have your own personal investment advisor, right? Or you have things for fraud where it's able to detect fraud for you, right? And all these fraud cases that we have been hearing recently, all of that can be captured via that. Same way with life sciences, healthcare, you would have seen cases where it's able to understand cancer, right? And predict the cancer for that. It has been in the news where it has used all the information, imagery, right? And even understand the DNA. It has gone to that level where it can figure out, okay, not now, but maybe after a few years, there's going to be some problem with you, right? Or if there's a cancer early itself, it can detect and warn you that there's a cancer happening, right? So a lot of these things in life sciences, healthcare, and medical are being done using generative AI. It's able to help you out because you have that information. The model is able to understand and tell you. Clinical trials, lot of medical people are using that. Same way with technology media, right? You have these short stories or short movies being created, which were not possible earlier, right? So you just tell, okay, I want this story, right? Or any movie or any kind of content, and it is able to create that content. So a lot of these things are some of the sample use cases by industry. And yeah, if you have any such ideas or you feel where it can be leveraged or you have questions around that, feel free to ask. Because I just have like one more slide, right? After this, so I want to understand in terms of the applications because the focus also was on more applications. So these are some of those use cases and applications where AI, Gen AI, right, can be leveraged. So based on your research, what are the things that you feel can be used by Gen AI in your day-to-day work for personal usage or for your professional usage? Feel free to call out. So these are some of the tools, right? I've been talking a lot about Gen AI, but these are some of the tools. This is not an exhaustive list, right? But just initial popular list, and there are like every day there is a new tool being created. So this will not be up to date. But if there's something that you are trying to build or you're trying to use for yourself, right? So these are some of the popular tools. So ChatGPT, you know, Google Gemini is there, which was Bard earlier. You have Bing, you have WhatsApp, Meta AI, now DeepSeek, and so on. So these are all chatbot, right? You ask a question, it will give you an answer. Then for video, there are tools like Runway, Pictory, Descript, which will create videos for you. So if you want to make fancy videos or you want to edit videos, right? What you used to do, you used to go to Adobe and make edits, right? And all of that for your photos and videos. Now you don't need to do it yourself. You just need to tell, like, okay, remove this person and add some person, right? Or make some changes in the background. You just need to tell. You don't need to yourself do it. So it has become so easy with all these video tools. Same way with productivity, right? You have all these task build tools that you just need to say and it will build something for you. Same way with designing. Like if you are into app development or you want to build some website, you just tell it, it will create 70 to 80% of the app framework and the website, and then you can make some changes to it. Same way with websites, codes, right? Copilot, content, presentations, everywhere, right? Like these are some of the tools for day to day. Most of you, if you have been using, you'll find it very useful. So that way you leverage these tools and make your job easy, right? So you can focus more time, you can be more efficient, right? Being more efficient also means having more time for your family or for things that you want to do for yourself, right? Everyone has a passion for something. Some would like to say play sports. Like I'm into sports, so I want to play a lot of sports. I can utilize my time playing sports, or I can utilize my time reading something that I love to read, right? Or play with kids or do something, right? As a passion. So these tools will help you save a lot of time. It will also build your knowledge, right? And you will be in demand for anything that your company or organization or college wants you to do. So if you are into teaching, you can leverage these tools. If you are into something else, you will find one of these tools, or like there are more newer ones as well, that will help you become more productive, and you can finish the job like in less than what was expected earlier. So how many of you have used how many tools from this list? Can you ping in the chat? Can you tell me? So I see a hand being raised. Feel free to ask a question. Any questions?
Am I audible?
I can hear you now.
Abrar, regarding actually, my question is linked to your previous one. You asked about there are so many field in that one. As
Yes.
a mechanical engineer, since I'm working in the finite element modeling part, so because FEM is again it's a big completed tool of which is having so many new mathematics in that one. It's already one types of mathematics complete equations form. So how far till now that AI has touched the AI, FEM or CFD or these kind of areas till now? Any idea?
Can you expand more on FMD? What is FMD or that?
FEM method in the sense before doing experiment, real experiment in civil engineering, mechanical engineering, what we do normally we do some mathematical calculation. We try to find out the stress in particular
Okay, yeah,
process that
simulation.
one. And then we do simulation. Then
Right.
we predict what kind of stress may generate in particular, either using some manufacturing process, welding, some cutting, whatever the process are there. So based on the mathematical equations, based on the physical properties of materials, we will give input and then we'll try to calculate and we predict these are stresses, these are the distortion. So any idea about how the AI has touched this area till now? How much?
Yes, for sure, right? So a lot of these calculations that have been happening, right? And if there is like a formula, or if it is something around like calculating, like you said, for simulations and understanding the stress. So a lot of these tools so have that ability, right? That can understand all this information, and so the way you need to tell that information also plays a big role, right? So you recall that prompt engineering, you would have heard that a lot. So you need to kind of define saying, okay, I am a lecturer, right? And I'm a mechanical uh, lecturer or a graduate or person, and I'm trying to do these things, and these are some of the things that I want to test out. So if you put that as a person, as a leverage, so the chatbot will understand what is the persona and what you are trying to do, and it will answer questions accordingly. So most of like if it is like very advanced calculations, so some of the applications are still being developed to go into the most advanced stage. But for like basic to intermediate calculations, chat gpt, there are new versions of that, meta ai, right? They can answer questions for you. It is able to like reasoning, like deepseek right now was launched, right? So some of these newer tools that are being launched, they are able to understand and reason and calculate these things. But for very, very high level, like too complex, it's still not yet there. But hopefully in the next year or two, we'll be able to even get more high simulations and complex things that are being done by these chatbots. You just need to define and give inputs and it will be able to execute. But right now it is more at, I would say, beginner to intermediate level, not very, very advanced. But it will get there soon because it's learning, right? And it will understand and it will then implement. Hope that answers the question. Any other questions? Any comments?
No questions, sir. I just request you to please share the slide to all of us.
Share this.
Session slide to all the participants.
Sure, yeah, I'll coordinate with Mr. Zubair, right? And I'll try to share the slide. But there are like any other things, like what are the things that are interesting for this group, right? If you tell me, I can explain some of the things better, right? If it is more in terms of how you can use
How
applications or
many automotive industries plan to learn their self-driving car. So for me, thinking that the problem is measure to sudden response in case of some obstacle incoming. So when it will be properly.
so the self-driving cars, right? If you see in US, there are many now, Tesla, for example, right? They have this option where you can put it on autopilot and it will do a self-driving car. So if you see the number of accidents that have happened, they have gone down in the past many years, right? So again, like I said, it cannot be 100% because these are all algorithms and probability models, right? Statistical models. So it can never be 100%, but the number of accidents that are happening, say via a person, right? Where you are a manual person, like driver driving the car versus an AI or Gen AI autopilot kind of a thing, the difference has gone down a lot, right? So there are more accidents by humans compared to a bot, right? So you'll never find it to be 100% accurate, but it is getting better and better with more data coming in. So the number of accidents already have gone down. And if you compare it with humans, it is less, right? So human will get tired, right? Human might do drink and drive, right? Lot of things happen, like they'll race or whatever, right? But these AI tools or these AI applications, Gen AI applications, they don't have that kind of behavior, right? So they will always be consistent and they're improving every second, every month, every year, right? Because they're getting more data and better the data, more the data, it will be more accurate and you will find like almost zero, right? It can never be zero, but almost zero kind of accident. So all these obstacles it can identify and it is able to do all of that. In US, you have seen many such. In Europe also, there are like trucks that are just you put a transport, right? And it will take you to your stop. So a lot of these testing and actual examples you can find on the internet where it has been successful. Some places it has not, it is still improving. But over the next couple of years, you will find more and more such cars that are don't have humans, right? Or human will just sit in the side and the car will drive by itself or the truck will drive by itself. So you can imagine like how much efficient and useful it will be. There's already better, I would say, than what the humans are doing in terms of accidents. So that's a plus.
Thank you, sir.
So yeah, there are like 80 plus people, right, on the call, 74. So hope this session was useful, right? If you have any questions or If you want to know more about something, I can go back and explain those things in detail, right? Where do you feel you can utilize it the most, right? What are those things that you feel you can efficiently understand and learn from this and make yourself more productive? At the end, that's the goal. All these applications, right? You need to understand and utilize it. Feel free to just ask, right? This is the time.
Anyone is having questions related to this session, you can ask.
Sir, may I ask one question?
Yeah, please go ahead.
Sir, there are certain GPTs which takes our personal information, and normally that information is updated in their database. And in accordance with those updates, day by day, they are taking from us. We get customized results in the future.
Yes.
But is there any possibility of becoming the misuse of that data, or stealing of the some sort of stealing of that data, or should we rather go for a cognitive mode, so
Incognito mode,
that
right? Yeah. So very good question, right? So these are some of the things on this slide I had highlighted, right? Which is privacy, ethical use, right? And even in terms of fraud that is happening, or any kind of this issues with the data. So there are two things to it, right? So if you have the data, your own personal data, right? It can be basic information about you, or it could be confidential information about you. So when you're using these applications, and it is not for GenAI, just GenAI, right? Even if say you are using Google, right? Gmail application or any other such free applications, if you go and notice on Play Store or App Store, you will see that you have a information where it will say, okay, this app is capturing your data, right? So there are benefits as well as there are disadvantages for it, right? Because sometimes that data is very confidential and personal and private for you. You don't want to kind of share. So there are ways as per the privacy laws that the government sets, right? So Europe has very strict policies around that. GDPR is the law. Same way US has bit lenient. India also has just last year created a policy around usage of data, right? How the companies can, because they're providing you free information, but it's not like they own you, right? The companies. So there's still, there are laws that they need to govern. Like, okay, if you are not using the application for whatever period of time, it has to delete the data. It cannot capture the data. There are clearly you have to agree to provide data to them, so the consent is needed, right, in many of these things. So it will be like a small star somewhere, and you need to go and check box or uncheck something. So there are definitely possibilities that someone will hack information. You would have seen already in the news that these companies, some of the companies get hacked, right? And people share information, confidential information about the customer, about address, phone number, email ID, passwords, right? So we need to be really careful when using applications. And I would say, like, use applications which are really branded, right? Or more good companies that are there, instead of just going for any free application, because some of those fraudsters and people who want to kind of hack you and take your money, right? They will try to do all these spam and such kind of apps that will take your information. So don't fall for free gimmicks, right? You will see on WhatsApp, okay, if you click on this link, you get free iPhone or free this or free that. Nothing in the world is free, right? We need to remember that. So don't fall for such kind of fraud schemes and easy to get money schemes, because they will then capture your information and like, yeah, utilize that information to defraud you of money, right? Or they will do any kind of blackmail sort of a thing. So be very careful. Understand when you're using an application what that application is, how it is capturing your data. So read through some of those terms and conditions. Some tools are really good, some tools are not so good. So we need to do our own due diligence, right? And understand and read some of these privacy laws. Government is also trying to do it, but we as consumers, we should be careful of what we are using. Don't fall for any kind of free schemes. That's what I would say.
Thanks a lot, sir.
And just adding on to that, right, you will also see a lot of fake news on media, right? Social media or even like TV media and so on. So we need to be, in today's world especially, we need to be very careful of what information we are seeing, right? On WhatsApp, people will just forward blindly any information. So don't fall for all these, because these are now fake images being created, fake videos being created, right? You will have someone saying something else, but it will add some other voiceover to that and call out. So always cross check the information before kind of understanding what if it is really true or fake. It is what it is, right? It is Gen AI world. People use things for good as well as bad. We have to be careful and educate, I would say, others about this.
Sure, sir.
Any other questions? Look, I'm here, right? I have another 10-15 minutes. So anything, personal usage, professional, how you can get better yourself using this, I'm happy to answer to my best ability.
Anyone is having question? You can ask.
Hello.
Yep. Hello.
Hello. Good evening, sir. Sir, is
Good
there
evening.
any AI app or AI technology which can understand the lip sync and which can understand the language what we speak, and that can be converted into any other form of data?
Yes. Yes, there are many such applications that are trying to translate, right? And understand what you are saying and translate it into other language. So there are many such applications. I don't remember the top of my head, but I can search and tell you back, right? So which are companies that are building these applications, because even in India, right, we have so many languages, right? So for people to understand, especially companies, if they want to say broadcast their message, right, they can create it in one language and it will be able to convert that into hundreds of languages. So those are some of the tools, right? Even while listening. So if you are talking something, the bot is able to understand what you are saying and it will be able to answer in some other language. So there are these tools being created, and I had listed some of them here in that last slide, right? So some of these tools like video and designing, right? And there are also image ones on about Adobe and stuff. So a lot of these tools for content, they are trying to understand what you are saying, right? And convert it into multiple languages. It obviously it won't be able to do for all the Indian languages or all the world languages, but they have started, and at least like the top 5-10 languages in the world, they are able to do it. So from English to Hindi or Marathi, right, or Spanish and so on, it's able to do some of it, not all of it. But in the next 1 year or 2 years, you will see, if it's an Indian company building, it will try to make it for more Indian languages. It's a foreign company, it will try to make it for other foreign languages. So already there are such companies. It's not fully up there yet, but in the next 1 year, 2 years, You will find it for many languages. Even it
Thank
can
you. Thank you
speak
very much,
to
sir.
you on the same language, right? So there are being tools developed by companies. So that's where I
Thank you,
feel
sir.
like the next level is there. Yeah. Thank you.
Yeah, Abrar Saab, good evening. This is Ibrahim. Am I audible?
Yeah, hi Brian.
So actually, just I wanted to know, like, will you please share a few applications or maybe websites where we can get the slide deck prepared, or I mean, you must be using.
Presentations, right? So those are this presentation. So if you're talking about PowerPoint presentations,
Yeah.
right? There are some of these that you can see here. The other thing, what you can also do is you can use Chat GPT, right? Or even Meta AI and ask the same question, right? Saying, okay, what are the latest tools that can help me with my PowerPoint, right? I'm trying to create a PowerPoint. What are the latest tools that can help me with building a PowerPoint? Right? So you will get those answers because every day there is a new tool being created, right? So beautiful.ai is one of those tools, right? Gamma I've already listed here, which can help you, right? So Dectopus. So these are just sample tools, but every day there's a new tool or every week there's a new tool being created for presentations, for code, for websites, right? So I don't have like what is the latest, but these are some of the ones that are there. Plus, like I said, you can ask Meta AI, right? Everyone has WhatsApp. So just go in, right? Just for yourself, right? Try what are the latest tools that can help me in building a PowerPoint deck. So you will find some of these tools like Gamma is there. There are many, right? Canva is there. That's also trying to add more templates. So Tome, Dectopus, all of these are there. So these are the ones that are there specific for PowerPoint. There are many more as well. Do try it, right? And let me know if you're able to get similar answers. So if you have a paid version of Microsoft, they have the Copilot, right? In PowerPoint and Word document, Excel, emails, even Microsoft Teams, right? There are Copilot by Microsoft. So it will be able to summarize conversations, create powerful decks for you, right? It will not do 100% again, like I said, no tool can do 100% of it, but even if it does 60%, 70% or 80%, right? That saves you time. You can just do rest 20-30%. So it's saving you that much time. Do try some of these tools. Like Copilot is definitely Microsoft Copilot is one good tool, and all of the other ones, Gamma, Tome, and others are also there. Any other questions? If not, can stop.
Good evening, sir. I have a question. May I ask?
Sure. Yeah, go ahead.
Actually, it is more general question. Actually, I would like to know your view as you are a AI expert. I can see the next generation is more dependent on AI. So for them is like they don't do hard work to learn the things. So it like it will help them in future or not? Like because they are more dependent on the AI things. No, they are everything is ready for them.
Correct. Very good question, right? So, and this is some of the things we have seen, like I have also seen personally, right? Because people are dependent, right? They are getting dependent on these tools. So they are not using their own creative mind, right? We all have, like God has given us good minds, right? Brains to understand and be creative. So what we have to do, as I had initially called out, right? We have to leverage both, right? It's not like we get fully dependent on AI tools. So what I have seen from my personal experience, as you have asked, right, is you have to have strong fundamentals because tools will change, right? AI will change in the next few years again. Like there'll be something new. Agentic AI is coming, robots are coming, right? So you need to have good fundamentals. So if you are teaching your kids or teaching your students or anyone, right, about how to leverage AI, my suggestion would be understand the fundamentals, like what AI is, what are the good things, what are the bad things, right? And using these fundamentals, if you have strong fundamentals, right, in mathematics or anything, right, you will be able to learn new things faster, and you will not be just dependent on some of these things. And one other thing, as I had highlighted earlier, as these tools are not 100% accurate, right? So you need to use your own judgment, right? And figure out some of the times like what is right, what is not right, and where you have to come in and make it better. So your own creativity, your own experience plays a big role. So my suggestion is fundamentals are really important. So whenever we tell students about this, I would say don't be dependent on just the AI tools. Utilize your knowledge, have good fundamentals, basics should be strong, so that way some you don't need to be dependent on these tools, just on those tools, right? Every day there will be new tool coming in or new technology coming in, so you have to be strong in that and utilize these tools, but don't be dependent on them. Have strong fundamentals.
Thank you, sir.
Thank you.
I think no one is having question now. Okay, on the behalf of Aditya University and Department of Mechanical Engineering, I conclude the first day of our AICT online FDP AI in simulation and additive manufacturing, and I take this opportunity to express my heartfelt gratitude to those who contributed for making today's session insightful and engaging. First and the foremost, I sincere appreciation to our esteemed speakers for sharing their valuable knowledge and expertise. Their insights have provided us with a deeper understanding of AI applications and simulations, and in different, like previous session, Dr. Ashutosh Mishra has discussed about the additive manufacturing detailed informations. So I thanks all the participants and speakers for your active engagement, thought, and provoking questions, and keep interesting made the discussion more meaningful. I request all the participants, please fill the feedback form for the both sessions, session 1 and session 2. And we'll meet tomorrow 6 p.m. for third session. Thank you. Thank you, all of you.
Thank you, sir. Thank you so much.
Yep. Thank you all. Bye.
Sir. Thank you. Thanks a lot.
No feedback link for session 2.